Okay, hello everybody. Teron Sibley here, getting ready to get my week 4 presentation on the foundational principles of WAN design. Um, Please forgive me. I am currently on vacation right now in Poland. So if there is anything in terms of background noise or anything that seems distracting, I am with my family of 4. So here we go. All right, so welcome to today's discussion on modern WAN design for the large global enterprises. In the digital transformation era, interconnectedness and WAN seem to be the backbone of all of the organizational communication, collaboration, as well as data transfer across vast geographical distances, right? So as the enterprises tend to expand their footprint globally, the demands are placed higher on WAN infrastructure to go exponentially. So today we'll talk a little bit about some of the details of modern WAN design and how it addresses the optimal requirements of high network service availability. We'll have flexibility, resilience, a little bit of information security, and after some edge computing stuff in there as well. All right. So let's get straight into it. So talking about the high network service availability, right? So as you guys see here, do have a figure that covers GEO, LEO, as well as the terrestrial networks. We'll go into a little bit of detail about that one. So, so whenever I break down kind of what high network service availability is, so achieving high network service availability is definitely important for any enterprise, especially whenever it comes to downtime, as that can be a significant loss in revenue, damage to the reputation of a company, as well as disruption to critical business operations, right? So we want to be able to ensure that companies have uninterrupted connectivity, and enterprises must implement some type of redundancy at every level to make sure that their network architecture is all secure. So for instance, right, maintaining multiple carrier connections, utilizing diverse routing paths, and employing automatic failover mechanisms are all crucial whenever it comes to minimizing downtime if something were to happen. Excuse me. We'll hit GEO, the geosynchronous Earth orbit, right? So generally composed of more than 3 geosatellites capable of achieving full coverage in low as well as medium latitudes. However, the transmission data process does suffer significant loss and long delays. LEO, however, this middle layer right here, the LEO is a layer that is in the low Earth orbit that typically consists of several groups of low Earth orbital satellites with minor loss and shorter delays. And this is a citation. You'll see my references on the final slide. So let me give you guys an example, right? So let's imagine an example where military forces are deployed to a remote hostile environment, carrying out an important mission, right? So in such critical situations, constant communication and can be a lifeline as well as that's necessary, right? So it keeps our troops connected, informed, as well as safe. So in these challenging conditions, achieving higher network service availability is definitely important. Our military does rely on resilient communication networks that ensure that vital information can be transmitted reliably, securely, regardless of whatever obstacles we face, right? So redundant communication systems from satellite-based networks to terrestrial-based networks, right? So whenever I say satellite to terrestrial, you'll see here we have an aircraft that typically communicate with low Earth satellites, and that hits some type of a station, ground station, or other aircraft. And so what that does is it gives us the availability to go from typical LOS line of sight transmissions to now it allows us to communicate over extremely long distances, right? So with these servers, they provide lifelines, providing our troops with the necessary connectivity to stay in touch with command centers, as well as coordinating with supporting units, and as also collaborating with allied forces, right? One of the things that the military does use, it is a program called SATCOM, Satellite Communications, which is definitely super important in the military communication infrastructure because it offers dependable connectivity across long distances. But it doesn't technically stop there. We also have backup system and have alternative communication methods like HF, high frequency radio, and tactical data links. We call that TACAN. That's ready to kick in immediately, right, to ensure that our people do have communication no matter what the circumstances may be. right? Typically TACAN, that's something that's going to be line of sight. So if it's an obstacle, whether that be a mountain, a building, or anything of that nature that blocks that line of communication for the HF, high frequency transmission to be connected, then that'll definitely hinder our ability to communicate over long distances. So this is managed by typically avionics as well as communication technicians in the Air Force. This also offers two layers of redundancy in terms of human capital, right? Personnel. Just in case if somebody is ever unavailable or incapacitated, you do have multiple people, multiple career fields that can work on these systems. Um, we also use sophisticated network management as well as monitoring tools to maintain a high level of network availability. These tools typically allow us to proactively identify and address any potential issues before they disrupt our operations, as well as creating some type of automatic failover mechanism and rapid reconfiguration capabilities to ensure seamless operations, as well as continuity even in face of network outages or being in a contingent environment, right? So next, so I'll start this one over. So flexibility, right? I do have a figure here. I will explain that later on, right? But I'll be covering the differences between traditional WAN as well as software defined wide area networks, right? So in today's dynamic environment, right, adaptability is definitely critical. Flexible WAN design definitely enables enterprises to respond swiftly to change, as well as different types of traffic patterns, right? So using technologies like software-defined wide area networks provide centralized control as well as programmability, allowing for dynamic routing and application prioritization based on real-time requirements, right? So um, Nowadays, SD-WAN is considered a technology that has potential to revolutionize WAN surface usage. It supports a new concept known as application-driven networking, where the network is expected to accommodate the needs of an application, services, as well as the customers. So this concept allows SD-WAN service to replace traditional WAN services over costly, different multi-protocol VPNs, as well as different types of technology that reduce network administrative costs and provide centralized and automated administrative elements. Right, so I'm gonna go a little bit deeper into dynamic traffic routing. Let's just say, for instance, right, the Air Force will dynamically route traffic based on application priorities, right? So what that does is different network conditions as well as security policies. So like flight operations data, that'll take priority over different like administrative tasks and things of that nature, right? To kind of maximize for optimal performance as well as responsiveness based on the needs of the organization, right? Now talk about centralized management. So with centralized management, this type of network management as well as configuration definitely needs to be something that is centralized, right? Giving administrators greater visibility as well as control over the entire network infrastructure. And this centralized approach kind of simplifies deployment of a new program, monitoring, troubleshooting, different processes, as well as reducing operational overhead and improving on efficiency, right? And lastly, secure connectivity. Right. So with secure connectivity, definitely important, especially whenever it comes to the Air Force as well as other military operations. SD-WAN solutions offers built-in encryption, authentication, as well as access control mechanisms to secure data over different data transmissions. Sorry, over different networks, right? Also, SD-WAN platforms also offer a seamlessly integrated security framework, so stuff like firewalls, intrusion detection systems, things of that nature to enforce the consistent security policies across the different networks, right? So here we show a picture of a traditional wide area network compared to SD-WAN, right? So here, point to point, definitely multiple points of failure. Definitely harder to keep this secure, right? If you're only controlling one area versus a software defined, right? Where now we have CPE, which is the customer premises equipment. Sorry, just read my notes. This is equipment that is installed based at the customer site, right? So this will be something that'll be installed on, let's just say, like an aircraft, as well as something that is installed on a data center or from data center to data center. Well, not only do they have multiple protocols, but now they also have broadband access as well as 3G, 4G, also 5G, which isn't being shown in the picture. But yeah, differences between traditional versus software-defined wide area networks. All right. Now we're going to hit resiliency, right, which is a pretty interesting one. I was able to find some information about how Ukraine, how their infrastructure is kind of tied into Russian networks as well as European networks, right? So with resiliency, right, resiliency is the ability to withstand and recover from any type of disruption, right? So things that are being important, redundancy, diversity, as well as some type of a disaster recovery plan. All those things are super, super important whenever it comes to building a good resilient WAN design. So technologies like what we just learned about BGP routing offer alternative paths as well as an automatic failover mechanism, minimizing the impact of network outages. Right. So a real world scenario, the Air Force will leverage resilient WAN design technologies like BGP routing, a cyber-based protocol, connecting tens of thousands of different autonomous systems, right? Which is what we see below that compose of the internet, right? And Internet of Things. So based on like a 35-year-old technology, this protocol is easy to manipulate, reroute internet traffic, or cut off entire regions, right? So known as a BGP hack, which is one of the methods that Russia used, but whenever they first invaded Ukraine. So it supports mission critical air operations as well as forward operating bases, FOBs, in a remote as well as a hostile environment that connects those people with other centralized commands, right? So what we see here is we see the Ukrainian network, right? We see like major international autonomous systems versus the Ukrainian ones, right? So the Ukrainian one is only centralized in Ukraine, right? But they tie into Russia, they tie into the European one, and then they tie into that level 3 here of the rest of their internet, right? And so what Russia would do is they would cut them completely off, or they would control a portion of their network. That way, they can try to manipulate the people based off of giving them specific information that the Russian political party was trying to throw into those citizens, right? But whenever it does come to resiliency, right, we'll hit redundancy. So multiple communication links as well as satellites, microwave, as well as terrestrial connections, like we talked about earlier, will be deployed to provide redundant pathways for data transmission, right? So this redundancy ensures that alternative pathways are available to maintain connectivity if one communication link becomes compromised or failed due to environmental factors or enemy actions, like what we just talked about. Next, right, diversity. The WAN infrastructure would kind of combine diverse routing paths as well as communication mediums to minimize risk of single point failure. Exactly what we see here, right? It would cut one off, and you still have the opportunity to not only communicate with the internet, but to communicate with different military Internet of Things, so IoTs, right? So for an example, right, MPLS technology enables the Air Force to establish multiple routing paths between network endpoints. That way we can make sure that the traffic can be rerouted dynamically during a network outage or some type of a congestion. Also, diverse communication mediums such as like fiber optic cables, microwave links, satellite connections, all those things enhance resilience by providing alternative transmission routes. Um, Now, lastly, right, disaster recovery plans. Another thing that the Air Force uses would develop and implement comprehensive disaster recovery plans to mitigate the impact of network disruptions or emergencies, right? So that fail safe. If something does happen, if we are hacked, what's our go-to to kind of make sure that things get up and running smoothly as quick as possible. So with these plans, right, they outline those procedures for not only getting back up, but reconnecting, prioritizing mission critical traffic, right? So somebody searching on Google will be a lot less important than mission plans and stuff like that, as well as activating backup communication systems in case of a network outage or some type of a cyber attack, exactly like what Ukraine recently went through. All right, so next, kind of going to hit two in the same block, information security as well as edge computing, right? So information security, Definitely with the cyber attacks that are becoming more and more popular these days, safeguarding sensitive data traversing through the wide area network is super important, right? So things like encryption, authentication, access controls are all fundamental in order to secure a WAN design. So using technologies like VPNs, firewall segmentation, all those things help prevent unauthorized access or interception of confidential information. Um, let's talk about cloud integration, right? Whenever it comes to information security. So SD-WAN as well as information security, cloud integration, all those things revolutionize the WAN management by optimizing performance as well as resource allocation. Cloud integration also offers a super smooth extension of network capabilities, right? So by leveraging cloud services, companies can enhance scalability, security, as well as accessibility across different distributed infrastructures. Excuse me. All right. So another example, right? Let's just say service members, right? We've always relied on hard drives for like critical data, and that's always created a challenge for limited accessibility as well as security concerns, right? What happens if you lose it, you drop it, somebody gains access to it some other kind of way. So to address this, we transitioned to a cloud-based storage using Microsoft OneDrive, right? Military has its own version of OneDrive. So OneDrive offers a seamless accessibility enabling service members to access their data from anywhere that we have internet connectivity. Right. So what this does is it streamlines our operations, as well as it ensures that we have our critical data always at hand, right? As long as we have a computer. So for data, extremely necessary for stuff like technical orders. We call them TOs that have been revised for like specific airframes. Personal data. So like if you're transitioning from one base to another, we'll have all that information as well as talking papers that provide leaders with the feedback necessary as to what challenges team members are facing, no matter what those actions may be. Right. OneDrive also offers super robust security measures, including encryption, access control, mitigating the risk of unauthorized access or any type of data breaches. Automatic backups also further protect against data loss. Centralized management also is another one of those things that consistently provides security across installations, enhancing administrative oversight as well as streamlining governance processes. So we also integrate with Microsoft 365. Application needs facilitate collaboration as well as productivity, no matter where you are located in the world, right? So a really good example of this is whenever, like for my job, I communicate a lot with the Air Force's Air University. This is located in Montgomery, Alabama. Typically, I have no problem entering video chats as well as doing a bunch of other features that keep us in contact with one another. So with this, right, I can ensure that we're all on the same page and can all receive the exact same information at the exact same time, right? Um, we also have initiated a phased rollout, providing some type of training as well as support to service members to ensure that they know how to use all these programs, right? So next, I'm going to hit edge computing, which is going to be covered in this figure here. All right, so edge computing enhances WAN design by pushing computer resources closer to the network edge, right? So minimizing latency, optimizing application performance, as well as enterprises can now improve response times, as well as enhance the user's experience by offloading processing tasks to edge devices, particularly for latency sensitive applications. So a really good example of that is let's picture a situation where we're trying to conduct a ISR, intelligence, surveillance, reconnaissance mission in a really heavy contested deployed environment, right? So rapid decisions are always going to need to be made in military operations, and as well as actionable intelligence. All those things are critical for mission success as well as force protection, right? So some traditional approaches to data processing as well as analysis involve transmitting raw sensor data to a centralized processing center for analysis, which also can introduce latency as well as bandwidth constraints, right? So impacting the timeliness as well as relevance of intelligence delivered to decision makers. So to address these challenges, one thing that the Air Force does is we've leveraged edge computing capabilities. So like deploying UAVs, reconnaissance aircraft like AWACS, ground stations, All those things allow for real-time data processing as well as analysis at the collection point, right? So I'll hit a little bit about how this works. I'll also talk about the different layers of edge computing as well, right? So first we'll hit the onboarding process. Edge computing devices such as like recognized servers or embedded systems, all these things are installed on ISR platforms, enabling onboarding process of sensor data as it gets collected, right? So what this does is this eliminates the need to like transmit large amounts of volume of raw data to a centralized data center because you can all do it in one shop, right? As well as it allows for analysis, slower, like reducing latency, as well as making sure that we have the bandwidth requirements in order for us to be able to do such things, right? So aside from that, we also have what we call UAV server task offloading. So what this does is, despite current advances, right, UAVs still face challenges to performing computationally intensive tasks because of the limited processing power as well as battery life, right? So UAV applications sometimes employ the traditional cloud computing model for processing power. And traditional cloud computing requires transmitting vast amounts of data over longer distances into and out of the core network, right, which can result in extended service latency as well as traffic congestion. So by shortening that distance between the servers, this is to like whenever we're trying to do like heavy processing and stuff like that. This allows edge computing to kind of thrive, right, where we can improve that latency as well as reduce the probability of traffic congestion. Finally, edge servers can be on the ground and or UAVs. For task offloading, it can be done for air to ground as well as air to air transmissions, right? So another thing that's super important is real time analysis. So edge computing algorithms are deployed for real time data analysis and intelligence extractions for sensor data streams, right? So by leveraging advanced analytics, machine learning, as well as computer vision techniques, actionable intelligence can be generated rapidly, providing situational awareness and decision support to mission commanders and warfighters that are on the ground. So dynamic tasking and retasking will be another thing that we'll talk about. So dynamic tasking, retasking, edge computing allows for dynamic tasking and retasking of ISR assets based on changing mission priorities, right, as well as emerging threats. So as the mission priority changes, we can also manipulate that as well, or the threat changes because stuff is happening so quick whenever we're out there on the battlefield. So by processing as well as analyzing sensor data on the network edge, mission commanders can make informed decisions almost as close to real time. What this does is it increases resource allocation as well as it maximizes our ISO operations effectiveness. And the last thing that I'll hit for edge computing will be secure data transmission, right? Because whenever we're communicating over vast distances, especially once we start to kind of consolidate the platforms that we're using, right? We want to make sure that all those transmissions are super secure. So edge computing does enhance the timeliness of intelligence delivery and all security. All of that stuff remains important. So secure communication protocols and encryption mechanisms ensure that confidentiality, integrity, as well as authenticity of data transmitted between edge devices, as well as central command and control centers, protecting sensitive information, as well as unauthorized access or encryption, right? So what we're seeing here, right, space layer, air layer, ground layer, right? What edge computing does is it, instead of it being multiple different entities that we have to go off of, like what you'll see here, because this is definitely something that is utilized, we'll use like a global hawk, right? Where a global hawk can be a one-stop shop. So what this does is it provides us a smaller footprint out there in that air layer and allows us to still be able to communicate, right? So you have something that gets transmitted from the ground to space, right? Because it's going over that longer distance. Hits that global hawk, it can either return back to the ground station or it get pushed out to a farther distance, right? To somebody that needs to hear it from a different location, right? So that's edge computing in a nutshell. Right. So lastly, we'll cover zero trust security, right? So traditionally, perimeter-based security models are needed in today's landscape, right? Zero trust security frameworks validate every user as well as device attempting to access the network regardless of location before giving that person access, minimizing the risk of insider threat as well as unauthorized access to anybody else who just simply doesn't need to be looking at certain information, right? So with the military, right, we do have, I will cover 4 different methods that zero trust security is implemented, as well as covering this really simple figure about like application clients, as well as different environments and that load balancer that kind of distributes all those things out. So first thing I'll hit is identity verification. So when people attempt to access like Air Force computer systems, they first have to authenticate themselves by multi-factor authentication. And this can be accomplished by using your common access card. We get a little card, we call it a CAC, and then typing in a password. Another thing that we do is device authentication, right? So addition to verifying the user's identity, Air Force also employs a device authentication mechanism to ensure that only trusted devices are allowed to access sensitive resources. So this involves like a computer automatically signing out and sending a distress signal to like a communication squadron, alerting that team that an unauthorized device has been plugged into a government computer. Right, so unauthorized devices can be anywhere from a cell phone, a human input device like a mouse, a keyboard, or thumb drives. Right. Excuse me. Next, right, is what this one is kind of covering, microsegmentation. So microsegmentation, so to limit the blast radius of any type of potential security breaches, people employ microsegmentation techniques to partition networks into smaller isolated segments, right, as seen in the picture. So each segment contains specific resources as well as applications and access between segments, all strictly controlled based on a user's role, permission, as well as the requirements of their organization, right? So for example, a communications airman can access the command line of other programs to enable administrative functions, whereas a normal airman who doesn't have anything to do with any of those systems, right? Obviously, you won't have access. That way we can mitigate the amount of damage that you can cause, or we can also minimize the amount of people that have security protocols that they don't need to have, simply put. And lastly, continuous monitoring, right? So rather than relying solely on perimeter defenses, the Air Force also use like continuously monitors the traffic of the network, user behavior, as well as system activity to detect as well as respond to security incidents in real time. So this is like whenever we implement security information and event management, whenever a computer is idle for more than a few minutes, it'll automatically log that person out to prevent any unauthorized access for anybody who may be on, right? And so what you see here in the figure is you see physical servers, virtual machines, VMs, physical servers, and then virtual machines again, right? So we might have a physical server that is tied to one area of the base, virtual machines that are tied to a separate area, and then so on and so forth, right? And so we'll use a load balancer to make sure that we are actively distributing all of the security protocols to whoever needs them, right? That way the wrong person isn't gaining access or to do malicious intent or to just simply be in an area where they don't belong, right? So today, right, we talked about virtual machines. We talked about zero trust security, information security, resiliency, all of those different things. Definitely some important information. Hope you all enjoyed my presentation. Thank you.